Okay, welcome to section 9.3. This video is going to be on what's called a geometric sequence. Right, so far this chapter have been mostly about arithmetic or arithmetic sequences, however the heck you say that. Now we're going to shift to do a geometric sequence, right? Here's an example. You can maybe even take a guess at what you think a geometric sequence is based on that example. Okay, before we dive too far into that, just a quick review of arithmetic sequence is a sequence where you add or subtract the same amount, and that amount you add or subtract is called common difference. All right, and so there is two types of formulas. There's a recursive one, and then this explicit one, which is likely the more important of the two, where you could find the value for any position using n. Right, so as a review, maybe pause the video here quick and see if you can write the explicit formula for this particular sequence. All right, hopefully you had a chance to do it. Okay, so basically we're saying the value at any position n is the first value, so -10, plus the common difference. So here we're going up by 2, which is 2, and then n minus 1, where n is the position we want to find. Okay, and then oftentimes we just clean this up a little bit by doing the distributive property and then combining like terms. So it'd be 2n minus 2, and then combine the -10 and the minus 2, -12 plus 2n. Okay, and we kind of know that that's correct. If we tried, like, the fifth spot should be -2. So if we just tried that really quick, you just put a 5 in for our position, right? We can kind of verify that we do get -2. 2 times 5 is 10 plus -12, -2. All right, so that's arithmetic sequences. Okay, so geometric then is a sequence where you multiply or divide by the same amount each time. And the number you multiply or divide by is called the common ratio, r, right? And actually, sorry, I said that wrong. The number you multiply by. So technically, a geometric is both multiply and divide. But if you think about, like, say, a divide by 2 sequence, that's really the same as multiplying by 1/2. So basically, when we do geometric, we're always going to do what we're multiplying by, not the divide number. And even though in some ways divide makes sense, we're going to say multiply by a fraction will help us figure out what r is. All right, and the key again for the formula, basically you're just going to need two things. An is like the value, and n is the position we're in. So those are kind of like our x and y variables. All right, and so for this first geometric sequence, the pattern is, if you haven't figured it out yet, is multiply by 2. Okay, and that's what r is going to be, is 2. So the formula is pretty straightforward. An equals the first term, which is 3, times 2 to the n minus 1 power, right? And the reason why this is, it's sort of like you start with a 3 and then multiply by 2 n minus 1 times. So that in the say if we just take the second position here, that 6 really is 3 times 2 once. So we don't have 2 times 2, so we have 1 times 2. Similarly, 12, right? 12 is really like 3 times 2 twice. And so if we put in n of 3 here, then we get 3 times 2 to the second, which is another way of saying 3 times 2 twice, right? So that would be how we'd figure out the third position, right? You just put it in for n. All right, that's kind of a lot of mumbling, but the point is this is the formula that would allow you to find any position. So if we wanted to find, say, the fifth value, obviously we could just continue the pattern, but we could also put in 5 for n and then figure it out that way. All right, so second one, same thing. So we're going to do our formula. So we got to do the first term. The formula is right here again. So the nth value will be the first term, 400. And then this time we are, what is that, dividing by, I think that's 5. It looks like we're dividing by 5 each time. So again, we want to use r is actually going to be what we multiply by. So just do the reciprocal of 5. So r is going to be 1/5 in this case. So we have 400 multiplied by 1/5, n minus 1 times, right? So technically it's divide, but we're going to write it with r of 1/5. Okay, that's mainly it for this lesson. Make sure you get the formula from this page, right? Here's the explicit formula for geometric sequence. So make sure you have that written down. And then the rest of these are just questions. I'm going to throw them up there, pause the video, try them, and then unpause to see if you have the right answer. So here's your first one, 3 separate questions. Are they geometric sequence, yes or no? And if yes, write the formula. Okay, hopefully got a chance to try them. First one, let's see. I think we're multiplying by 4. So that one would be geometric. And then the formula, pretty straightforward. First term is 2, multiply by 4, n minus 1 times. Second one is kind of a crazy one. It goes, there's a pattern there, +3, +5, +7. But it's actually not geometric or arithmetic. It is an add-subtract pattern, but we're not adding or subtracting by a common amount. So this one's actually neither arithmetic nor geometric. Right, and then the last one, so I guess this one would be no. And the last one is also not geometric. It is an arithmetic add to pattern. All right, write the 10th term. Again, pause the video, try it, and then unpause, see if you can get the same answer as me. All right, so we know the first, second, third. Hopefully we can see the pattern here is we're multiplying by 3, so it's a geometric pattern. And certainly you could just list them all out, right, if you wanted to do that. But I think a better way to do this, especially if it said like the 100th term, which would be a massive number, but if we had to do the 100th, then this formula is going to work a lot better, right? And it's really pretty straightforward. We just have 4 times 3 to the n minus 1 power, and then just put in 10. So a sub 10, which is the 10th value, 4 times 3 to the 10 minus 1. Okay, so now all we need is our calculator to do 4 times 3 to the 9th. And make sure you do PEMDAS. Do the 3 to the 9th first, and then multiply that value by 4. And so we should get 78,732 is the 10th term in the geometric sequence. Gets big fast, right? When you're multiplying by 3, the numbers are going to get big real fast. All right, again, a little bit different style. We know we want to get the first 5 terms and the explicit formula. And these are literally the only 2 things we need, right? So our formula, an, is the first term. Then we have to figure out what we multiply by, and then to the n minus 1 power. Sorry, that didn't look very good. But basically, that's it, right? If we know what the first term is, we know what r is, and we've got it. Okay, and so as far as our table goes, do my best here to write this out. The first term, we already know was 1. They told us that in the question. And the second term, we could just start to put in 2 for n. But what you'll find is you have 1 times 0.5 to the 2 minus 1, sort of the first. And so it's just like multiply by 0.5 once. Okay, and so basically what happens is each time n goes up by 1, you have 1 more times 0.5. Right, so when n is now 3, I will have 1 times 0.5 to the 2 minus 1 power. And so I just multiply by 0.5 from the previous term. Right, you can just say this, each time n goes up 1, you have 1 more times 0.5, and that just kind of makes it smaller each time. So the fourth term, I believe, would be 0.125, and then the fifth term, I should probably get my calculator to check this, but we multiply that by 0.5, I think it would be something like that, right? So it gets smaller and smaller as we go. Right, so again, you could put in all the numbers for n, or you could just know that that's how geometric works, is you start with whatever and then you multiply by that ratio. Right, that's really kind of the easier way to do it. Okay, so a couple other different style questions. I like these because they make you think. So again, pause the video, try it before watching my explanation. Okay, so we are given the 9th term, and we want to find the 10th term. And we know that r is -1/2, which means we're multiplying by -1/2 each time. So basically, if we're here, the next term we just have to multiply by -1/2. So this would be positive 2.5, right? If that has to be the pattern. All right, see if you can do another one, similar style, but slightly different. All right, so this one we just have to work backwards. So we know the 11th term, a sub 11, is 20. And we know that r is 5. So we're multiplying by 5 each time. So this would have to be times 5 here, which means we have to divide 5 to go back to figure out that this must be 4. And then we can kind of see that it works. 4 times 5 is 20. So the 10th term is value of 4. Okay, last concept I believe for this is we talked about arithmetic means when we did arithmetic sequences. And so the mean of that is like if I have two numbers, say so many friends Mr. Westphal has, let's say that she has about 10 friends, and we want to find the average of those. The arithmetic mean is you just add them together and divide by 2. Okay, and so that should be average of 6 friends between me and Mrs. Litzy. You can also do something called the geometric mean, and it's pretty different, I guess. You multiply the two values and then take their square root, right? So that's a way to average two numbers besides doing it the old arithmetic ways, to multiply them and then take the square root. All right, so you probably want to write down what a geometric mean is right there. And then, if you want to extend it, I guess if you want to do three numbers, if you had x, y, and z, you could do their geometric mean by multiplying them all together and then cube rooting. All right, anyways, that's a little beyond what we need. So for us to fill in the middle blank here, right, we know we're multiplying by something in this geometric sequence. And to figure out what the something is, you can actually just take and multiply 2 times 18 and then take the square root. We get square root 36, which is actually both 6 and negative 6. Okay, so that's why it says there's two possible values here. It could be both 6 and negative 6. Okay, and so this one kind of asks then, if we happen to know, sorry, I don't know why that doesn't write, but if we happen to know that the position here is negative 54, then you could probably guess, well, what has to be here? Okay, and so it looks like it would have to be negative 6, because then it would be a negative 3 pattern, and it would all work out. Okay, so technically there's kind of two answers if the way it's written originally, but if they tell you what the fourth term is, then you would know for sure how to do it. Okay, one more for you to try. All right, so to fill it in, just going to multiply 5 times 911.25. Take the square root of that. Sorry for the poor handwriting. And the eraser, that doesn't work. All right. There we go. And so when you do all that, you get like 67.5. And technically it could be plus or minus. So the missing term here, we would be either multiplying by a positive or negative, and that's why it could be both positive or negative 76.5. And it's kind of curious, like I was just thinking here, what is r? Right? So I know I'm multiplying by something. So if I didn't know, one good trick is you can actually do 67.5 divided by 5, and that'll get you what r is. Okay, and that should get you 13.5 or negative 13.5, depending on if we're alternating between negative, positive, or not. Right, so that's kind of a handy trick to find r's. You can just divide two consecutive terms, any two consecutive terms, and that'll get you what r is. All right, that's it. Next up is that online assignment for 9.3. Good luck. As always, reach out if you have any questions. Thanks.